Well, good evening, everyone. Hi, I'm Randy Johnson. Welcome to the Shark Laser Setup and Operation webinar tonight. We do have a lot to cover tonight, and we are going to be talking about the 2 watt and the 7 watt. The general principles we'll be talking tonight apply to both of them. There's a couple of applications that are a little specific for one and the other, and I'll be highlighting those as well. Starting off, of course, if you have the 2 watt, you can see the package there on the left. The control box or the power box that comes with it is pretty much the same as the one that comes with the 7 watt. The main difference is the wattage, of course. The next thing I want to mention is that the maintenance of the lasers is a critical element. So I want to hit that right up front. It's critical that you maintain the lens on your laser, that you use a swab and an alcohol to wipe it off. Do it at the end of each day or every 4 hours of continuous laser work, or next time just before you go to work. You will find after several hours of laser cutting, you'll get some dust on the bottom. It's basically ash. And that will not only build up around the inside of the hub at the bottom, but it also coats the lens. The type of laser that you're using here from Shark is called a diode laser. It's a colored laser, so it's actually a visible laser. What happens when that visible light beam comes through the lens, it hits the wood and burns it. However, if you get excessive dust built up on your lens, which happens naturally while you're using it, that dust actually reflects the light back up into the diode and will eventually burn it out. It's one of the common problems that people have if they don't maintain their lasers. So it's extremely important, much like lubricating bearings and stuff like that, but in some ways even more critical because it will technically fry your laser. That will be the end of it. You'll have to have it rebuilt. Another little bit about how these lasers work as compared to other types of lasers. I mentioned that this is a visible light laser. You actually can see the light beam coming down from it. Of course, make sure to wear your safety glasses if you attempt to do that, and of course, never stick your hand under it or point it at anything. That's why it's mounted vertically. But other types of lasers, like a CO2 laser, those are invisible light. It's a different kind of light beam, and that light beam cuts the material in a different fashion. So one of the limits that we'll talk about tonight with Shark Laser is it's harder to engrave on white wood or white surfaces, and it's very difficult, if not almost impossible, to cut, say, white paper with it, because the white paper simply reflects the laser beam away because it's a visible light. That's where you'll find that you actually get better laser burns on cutting something that has some color to it. Medium colored wood, alder, cherry, cut really well. Obviously, walnut even cuts better, but you can't see the burn on the walnut as well. Pine is much more difficult, partly because you have different colors of grain, so it's going to burn differently on each grain color, as well as the light wood. It takes a lot of burning. Sometimes I find on pine, I have to go over it 2 or 3 times in order to get it to burn. Also, NextWave doesn't recommend attempting to do any laser cutting or burning on plastics. All plastics give off hazardous fumes, and PVC in particular gives off highly poisonous fumes. So you just want to avoid those plastic products. You also won't be able to engrave on glass with this particular laser. However, if you have something like anodized or painted aluminum, it will often take off that surface. If you have a powdered coated surface on steel, it'll burn through that. It's not going to burn the steel. It's not going to burn the aluminum, but any coating on there, it actually will cut through. So that's another kind of fun technique. You can also cut a wide variety of materials, fabrics, leather, anything organic like that. It'll cut through as well. So I want to go over just some of the basic setup. These are some things that you'll want to do, not only for your laser setup, but for your CNC in general. Now, for those of you who have attended my other webinars this month, you notice that I've been promoting the firmware update. NextWave has released a major firmware update. Back in December, they released it, and they've been fine-tuning it ever since. This firmware update has some applications for a variety of their accessories, their tool in general. Overall, it's been a big push to improve the functionality and reliability of their electronics and programming in their controller. And there's a couple things in here that affect the laser as well. So some of it's all in the background inside the controller, the way it controls the moves in that, and some of it's on the pendant end of how things actually function. And for those of you who have a spindle with the interface speed cable, it's a huge upgrade because it actually allows you to automatically control your spindle, and it brings over all the RPM from VCarve. But for everybody else, it still has some functions that are really nice. I'm going to send out documentation that shows you how to go through the steps of upgrading your firmware if you haven't done it. The first time you go through it, especially if your machine is a year or two old, I'll admit, it's a little tedious. I went through it myself with my older machine, and it took a couple extra steps. But now that it's updated, I've gone through the process a couple times, it goes pretty well. So it's called Ready to Firmware Update. It's a piece of software that you'll download from your user account. If you have Ready to Control installed on your machine, which is the other control system that NextWave provides, you can also do it through that as well. Anyway, one of the functions that has changed on the pendant, as you can see in the picture, is that NextWave has now added a homing button up in the right, which launches the home routine for the XY axis. They have also split out the 0xy from the 0z, which is really handy. These are actually a couple of functions that I requested, and several other people as well. So it's really nice to see it there. Now, there's a lot of other things going on with the pendant that are improvements, but I recommend that if you haven't seen the pendant webinar that I did back in December, I will send out a link in the email for that as well. And it can also be found on the NextWave website. It's publicly available out on YouTube right now. And that goes through a lot of the changes that the firmware brings to the pendant. Also, if you haven't seen the webinar on the pendant in general, it also shows you how to get the most out of using your pendant. So I won't be going into much detail on the pendant in general. I will be talking about it specifically as it relates to setting up the laser and using the laser. But you can find a lot more about the pendant out at this webinar. The next thing is we want to go out and get the most current post processor for VCarve that applies to the Shark laser. One of the easiest ways to get it is go out to the website, go to the support tab and click on the download and links menu item. That will then take you to the downloads page. And as you scroll down towards the bottom, right down here, you'll see a laser module highlighted here. And if we look a little closer, you then see underneath the laser module, here's the Help Center link for post-processor information. So go ahead and click on that Help Center link. That'll then take you over to the Help Center page on post-processors. There's a lot of information here. It gives you the list of current post-processors based on your machine, but you need to scroll down on the page to find the laser information. And you'll come to this chart, and there'll be two of them here. It'll be the NextWave laser for inches and metric, depending on which setup you want. You can have them both. So when you click on that, you then can download it, and then it'll save probably to your download folder or something like that. But the other options, you could just move it to whatever folder you want it. At this point, I'm going to hop over to the software and give you a demonstration of how to actually install that post processor. To add the laser post processor in VCarve or Aspire, go to the machine menu, drop down at the top of VCarve, and go down to install post processor. That will open up the folders on your computer, and you can locate the post processor that you downloaded from NextWave website or the one that was sent to you from this webinar. Select that post processor, click open, and it asks if you'd like to make it the default. You don't want to make the laser your default probably, so click no. And now if we go back up to the machine window and look at the post processor management window, you'll now see NextWave Laser Post Processor listed here at the top. Final thing we need to do is go over to Machine Management or Configuration, and we need to add it or associate it with your particular machine. Now, on my setup, I have several machines listed here. I'm going to add it to the 510. If you don't have or see your machine currently listed, you can add a machine in a couple of different ways by hitting this plus sign and or downloading a machine configuration directly from Vectric. But once you have your machine uploaded and the basic configurations installed, I want to add a post-processor at the bottom. I'm going to click on the plus sign. That'll bring up my list of post-processors. Select the laser post-processor and click select at the bottom. That adds it to my list of associated post-processors for that machine. I then can click apply and OK. Now when I go over to my toolpath side of the program and I open up my save toolpath options and I look at my selected post-processors, the laser is now in that list. So I now have that available to me when I export a tap file from VCarve for any of the laser type apps. The basic setup, it's all covered in the manual, but you're going to hook up to your control box through the ribbon cable. You've got a key that'll turn on the laser control box, and then you're going to connect, of course, your power supply and your laser to that laser control box. The next thing you want to consider is your clearance. Now, I have this highlighted here that you can raise and lower your gantry and your HD tools. You're not able to do this on your SD tools. In general, you have plenty of room on your HD tool for your laser, which sticks down several inches. But one of the things on the HD and particularly the SD tools or the Piranha tools, if you've used your tool much, you know it goes up for some clearance, some safe height as it's referred to. And you can adjust that within both VCarve and your Pendant. But you want to make sure when it goes up to its safe height that it's not bumping against the top of the tool at the top of the Z, because that'll throw off your settings. If you're working on some really thick material on the HD5 or the HD tool, you might run into that problem. And on the Piranha and the SD tools, you just have to watch the thickness of your material so your machine doesn't go up too high. Otherwise, you install it much like a router bit. You don't have to crank down on this collet really tight. Just make sure that it's snug. Also, make sure if you're using a woodworking router to turn your woodworking router off. On your spindle setup, of course, it's the safest thing to do is unplug your VFD so the spindle has no power, because you certainly don't want this to spin around while you're operating it. Now, a couple of settings within the Pendant that are worth looking at. If you haven't used the manual settings or controls by touching on these screens, we're going to take a look at some of that right now. This is a screen that I have in my Pendant Webinar class as well, and you'll have this screen available so you can look at it, and it's all covered in the Pendant Webinar, but each of those moves has a function. And within laser work, you're going to have the need to go in here frequently and make some adjustments, especially upon the initial setup. This is one of the first ones that I want you to look at. Within the apps window, you'll see the laser set up here at number 2 to access the laser menu. And then you have 2 items. You have a test laser to minimize overburn. For most of your work, you're going to want to minimize overburn. And to make that setting, again, you'll press on the upper right, move over here, and then you'll enter a 1 and an OK. And that'll enter the 1 for on. So minimize overburn is turned on. The difference of having overburn on and off looks like this. You may not initially see a lot of difference, but if you look here at the serifs, they're burned. They have overburn on them. They're much darker, and here they're not as dark. So in some designs, the overburn becomes a problem. Now, as I mentioned at the bottom of the screen here, if you're doing cutting through thin materials, then probably leaving the overburn turned off is probably acceptable. Or if you like this little extra flare at the corners of your lines and designs, you can also leave it turned on. But that's what minimize overburn does. It just lightens the burning around some of the corners and some of the ends of the lines. The next setting that's inside the Pendant is the test laser. And when you press on that, you'll get this additional screen to OK it. And when you press it, your laser will actually flash on a couple of times. This is mostly just to simply see if you're getting electricity to the laser. If you have it raised up more than the recommended amount, which I'm right now about 1 inch up, the laser beam itself is going to be spread out like a flashlight. It's not going to have much burning ability. It's going to be very much out of focus, and it doesn't even really work for lining up the laser, but it does give you a general idea of where it's going to burn. Even at 1 inch of height, this 7-watt laser will leave a mark on the wood. So if you're testing the laser, especially whether it's down or up like this, just be aware you could leave a mark when you're testing it. but it's mostly that test fire is mostly there to see if the circuitry is working. One of the other things I recommend people do is map out your cutting area. A couple of reasons, and I'm going to show you in a minute why it's important to know the limits of your machine. Particularly has to do with the laser movement. Actually moves beyond your design. You want to make sure you're not too close to the side of your machine or to the front of your machine, or it may bump into that limit of the machine. So let's just consider this the red bed of the machine. We've got the laser, that's the diameter of the laser. We've got a piece of artwork that we want to engrave onto a piece of wood. One of the things you want to consider is that that laser is going to move around the perimeter of that design area, and you want to make sure your clamps are out of the way. So that's a no clamp region, that yellow area, because the laser is moving around it. Now, it depends a little on which way you're cutting your file, but in this case, I'm rastering the file left and right. And in general, I like to leave the full diameter of the laser to the left and right of my design when I'm rastering. Now, it doesn't quite move that far. It moves maybe half of that. But been talking with the engineers, and they're looking at increasing some of what they call overburn and or overscan, which moves the laser a little bit further left and right. So just be aware it's going to be move that far. Also, you don't want your design up hard against the left or right or front of your machine, because the laser needs a couple extra, well, about an extra inch of space, and it would hit the hard stop on the machine. On the front and back on this setup, the laser is basically going to cut right along the middle of the laser, along the top and the bottom. So in that sense, I really only need a half an overlap at the top and the bottom when I'm rastering in this direction. I sometimes will add some tape to my table just to make alignment quick and easy, and also that I'm always within my range and clamp down. Now, one of the questions that often comes up is, how do I center my laser? And I'll admit it's a little tricky. A lot of what I'm going to show you today is kind of the basic approach. Once you do this, or you already may have another way that worked for you. Obviously, the middle of the laser is the part that you want to center. So this is one that I've come up with. I use a centering ruler. A centering ruler, as you can see in the bottom here, it counts left and right of a center mark. So when I lay it on my work, I've got 6 inches there and 6 inches over there. And then I put a couple pieces of tape on it, the diameter of my laser. So all I really need to do is lay that ruler on there and center it, and then nudge my laser left and right till it's between those two pieces of tape. And for most of the picture work I do, it's accurate enough. Once I've nudged it left and right, of course, I need to zero it to this location. So here's where a couple of manual steps come in. Now, I'm going to show you zeroing just the x-axis. I could, however, at this point, just click 0xy, and it would zero both of those. Then I could go back and do y, come back and click 0xy again. So if you understand using 0x, you can repeat it and you can get fine results. But I also just want to show you some of the power of using the individual setup. So if you press on this position window, it will then open up the x-axis editing window. And the next thing is you would type in a 0 and then click set. And what this is doing, when you type in 0, it enters it up here, click set, it's going to set the current location of the machine to 0 just for the x-axis. Next, you'll see this screen that tells you it's about to change the x-axis. You click OK, and it'll go over to the main screen, and the x-axis is zeroed out. Like I said, one of the reasons I like this technique is you can do each axis separately this way. Having done that, I then switch my ruler around and go the other direction. Go back inside. Now I'm going to do the y-axis. I do the same setup. I type a 0 in, press set. I get the caution window here that tells me it's about to make a change, and I make the change, and now both my X and Y are set up. Next, I want to set up my Z. So what I do for this is I make sure and flip it to slow movement for the jog speed, put a little piece of paper and slide that in and out, and then use my up and down buttons until that laser just comes down and sits right on top of that paper, just kind of snug. I then do the same thing as before or something similar. I go into my Z-axis window, but in this case, I'm going to enter 1/10 of an inch. I then toggle on the negative value. So it says negative 0.1 and I click set. So what I'm doing is setting the bottom on my laser 1/10 of an inch below Z0. And when I click on set, again, I'll get the notice that I'm going to make a change to Z. And I'll notice that in my main window, my laser, which is sitting on top of my material, is set at a negative 0.1 below Z0. And that's exactly where I want it, because I can now go back into this screen and click move to 0. And when I click move to 0 in the Z window, click there, it now moves it to 0. And at my machine, I now have a 1/10 of an inch clearance, because the setup that you want is what's shown here. You want the 1/10 of an inch clearance and you want the Z0 to the bottom of the shroud. So next up, of course, you're going to bring your file to your pendant. And what I'm going to do at this point is just run you through what's kind of the laser workflow. I'm going to show you the basic steps of loading a file and cutting it. We're then going to take a look at 3 pieces of software that are used for creating files for the laser. Well, actually, it's 4. There are 3 ways of doing it within VCarve. There's something called the Quick Engrave Toolpath, which is the traditional way of doing it. It's a very convenient, easy way. You just have to have a couple settings set up in a special way. And then Vectric sells a pair of laser apps. One's called Cut and Fill, the other's Laser Picture. They cost $50 when you buy them from Vectric, so they're extra, and you don't actually need them. Well, it depends what you want to do, but I'm going to show you tonight so you can decide whether you need them or not. The Laser Ready2Raster is great for rastering photos, and that's specifically what that's made for. That's a NextWave specific product, specifically made for the Shark lasers, and it's a free program that you can download from your user account at NextWave, and I'll show you about that tonight as well. So let's assume we've loaded up a laser file that we've created in one of these programs onto our thumb drive. We put that into the pendant. The next thing we're going to do, just like with CNC work, we're going to click on the USB button. Now, if you have your laser connected to your control box, you should get this extra window here that gives you an option asking you what accessory is connected. And in this case, the laser's connected. So we'll click on the laser, which will then take you to your typical file window where you then can select the type of file or whichever file you want to cut at this point. Just like with your CNC work, you would click on that file. It'll then bring up the next window. It gives you the G code for that file, and you can then click on next on that one. And at this point, it'll bring up your start window. When you click on start, the file is going to start moving, but the first thing it does is it moves to the start position. So I'd centered it out in the middle of my work. It's now moving to the upper left because that's the start position for this laser file. And after it moves to that position, you'll then get this sign. Now, what's really important is while it's doing that first initial move, preparing itself to start, don't touch this screen, because this screen will pop up, but you want to wait for it to complete its move. Otherwise, if you interrupt it with clicking OK, it may crash the program. But it's a known bug right now they're trying to solve. But the safe thing to do is just wait for the laser to come to its start position and pause, and then click OK. What this screen is really telling you is that it's about to cut what's called a raster file. There's 2 kinds of files you can cut. One's a vector file and a raster file. And you'll only get this warning when it's about to cut a raster file, which is what I have set up right now to cut. I'm going to raster that eagle photograph we saw earlier. But you can click on the OK button. It will immediately start burning. And you'll get your usual start window over here, your information window with the amount of time that's transpired, how much of the file has been transmitted, as well as the name of the file at the top. You can override your speed if you think it's going too fast, but generally I find that I just go back and rework my file and get a better file. So once that runs, you've got your burn. This is a eagle image that I burned on a piece of MDF. Taking a little closer look at it, that's the photograph I used. And this was the 7-watt laser, 50% power, 100 inches a minute. It took 25 minutes total. Now, again, this is done in Ready2Raster. This is not done in VCarve. So we'll be looking at both those programs tonight. There's another example. This is a 5x7. This was done with a 2 watt. So this took 2 hours to burn. But again, the 2 watt's only running 50 inches a minute, and it's a much bigger image as well. But you can see you get some real nice variations in the burn. Some people find that the 2 watt actually does better with photo engraving. It's a little more subtle, and the 7 watt is a little more aggressive. I agree. I think the 7 watt gives a slightly coarser rendering of the grayscale, but I actually am getting good results from both. You can do photo engraving with both of them. I mentioned earlier about two broad types of laser engraving or laser work. One is called vector-based. And so the vector-based, much like for CNC work, you have a vector. In this case, there's a T. And you could laser around the outside of that letter or shape, or you could do a crosshatch or a single hatch inside that. That could all be done within VCarve. A couple of the resources that are available related to VCarve, and this is one of the things I'm going to send out, is a test grid. And this file is a tap file. You don't have to create this in VCarve. All you have to do is put it on your thumb drive and run it, because all the settings are predetermined. And it's available both for the 2 watt and the 7 watt. And as you can see in the picture here, here's 100% power down to 10% power. Here's your feed rate from 20 inches a minute to 80. For the 2 watt, the sweet spot is thought to be right around 50 inches a minute at 100% power. So that's how that arrived at right there. Same thing with the line burning. You can see you get a nice sharp line. Down here, it's certainly heavier, and then it fades away. So you can take this grid, burn it on your material of choice, and then using this grid, you can decide which speed and power works best for your particular material. And this specifically applies to the vector line burning within VCarve, but you can carry some of this over also to the Ready2Raster file. So that's basic vector work. You could do a fill, as you see here, with hatches or very close lines. It almost looks like it's totally painted in. Or you could do the line. There is no gradation within these fills. What you see here is a little bit what's called overburn. As I mentioned earlier, this actually, you can see the overburn on that, and that can be turned off to minimize that shading on the side. But generally, when you fill something with the vector fill or the hatch fill, you get a solid color. Now, rastering, whether it's with the raster program with VCarve or the Ready2Raster, does allow you for gradation like we saw on the Eagle. And here's another example. This eye photograph, Ready2Raster allows you to do it in two fashions. One's called dithering. Dithering is basically a whole lot of little dots, in the sense of, you think the newspaper print, you have all those little dots. So you have a lot of little dots making up the image. And generally, dithering in Ready2Raster will give you the best kind of gray appearance or shaded appearance of your image. The grayscale is just the laser simply powers on and powers off as it goes along based on the variation. And this is a grayscale bird. These terms will mean a little more to you as we get into the software. But what I want to point out is, notice how along this bridge of the nose and the eyebrow, how virtually no burning going on. Where with the dithering, you have a much more even gradation of it. But I have found that depending on the effect you want, this gives you much more of a poster effect. But if you want more of a photographic effect, then the dithering is by far the best choice. Vectric also has a dithering option within their laser picture toolpath. And this is a toolpath. This is one of those accessories I mentioned you can buy, one of those two that you get for $50 for the pair of them. Now, this is a dithered image out of VCarve. Now, you'll notice, first of all, it's fairly coarse. It also takes a very long time. Now, there's a little caveat to this, and that is that the laser toolpaths that you could buy for VCarve, these two toolpaths you pay the $50 for, they're not fully compatible with the Shark laser system. And the main result of that is you're seeing very long burn time, almost 4 hours. And this picture is only 5 inches wide. You know, the last one we saw, we could do that with the 7-watt laser in a much shorter time. Also, the results are very different. If you see this background, it looks very digital, computer-like, because it really is burning out little squares of information as it goes along. And when it operates, it almost sounds like a little slow sewing machine, because it's pecking its way along. No matter how fast you set the feed speed, it just pecks its way along at a very slow pace, probably 10 inches a minute. So it takes a long time. It goes very slow. The results are very different. Might be appealing in some situations, but that's one of the choices. I'm not sure when this software will be made fully compatible with VCarve. I've been talking with both Vectric and NextWave, and they seem to have hit a bug to overcome this that is going to take some time. But in the meantime, this is the limit of it. So just be aware of that if you have this, you probably have experienced this. If you don't have this extra software, just be aware that there are some limits if you do decide to buy it. Now let's take a look at what it looks like in Ready2Raster. Again, Ready2Raster, this is still dithering, but look at the same image, 28 minutes is all it took to do this image. It's a much more even pattern, as you can see. The squaring is much smaller. It's far, as far as doing photographic kind of rendering and speed, it's far superior to the current rendition or the current version of the VCarve picture laser tool. So again, just another choice. We're going to take a close look at these as we get into the software demos. Now, you saw the chart earlier. I'm going to back up to it a minute here. This is the chart that you could run that was created inside VCarve, and it's particularly useful for vector carving, vector engraving. Ready2Raster also has a chart available, or a couple of them. And this is a grayscale because Ready2Raster is all about doing a gradation. And we'll take a look at it, but I want to show you how to read this. This is 0, which means totally black, and this is 255, which means totally white. This is a compressed scale. The same one is over here. You can see it turns out starts black up here and comes down to white on the right side. The one on the right here has a problem because the overburn hasn't been adjusted. And that is something that's supposed to be corrected very soon within Ready2Raster. So you shouldn't get that. You should get a much more even burn on this chart. But what this allows, if you choose to go in and fine tune some of your burning within Ready2Raster, let's take this one down the lower left. I could choose to start my black at 0 and then end my white, 15, 25% less right here. So I'd actually set up a range, a burn range that's called 0 to say 240, rather than going all the way to 255, because all this is dropping off at white. That way I end up getting a little more gradation on the picture. It's an advanced technique, and I don't even necessarily recommend that you spend a lot of time trying it. You can, but I'm going to show you some techniques within Ready2Raster that just use the standard settings and get really good results. In fact, everything I've shown you so far, those eagle heads, have all just been the standard settings. I haven't gone in and did any photo manipulation on those at all. But I point this out because you will come across this in the software. So at this point, I'm going to hop over into the software. I think before I do that, I'm just going to take a peek at some of the chat here and see what we've got going. If there's any questions I might address before we hop directly into the software. Right, so we've got a question here already about the VCarve laser program. I'm going to demonstrate that shortly, so you'll see what it does. You can purchase that from your user account or directly from the Vectric website. That's where you would get that. Do post-processors ever change? Well, yes, they do. They do change. There's a couple of things that they add to them to try and improve functionality. I would recommend, every 6 months maybe, go into that website I showed you, download the new version. You can always save your previous version. You can have multiple versions inside VCarve database. You just give them a different name. You can put a date by them when you downloaded it, so that if the new post-processor seems to cause you issues, you can always go back to the previous one. It doesn't overwrite the previous one as long as you give it a new name. Yeah, I don't have any timeline on when the laser app that Vectric provides will work with the Shark tools. I've not been able to get that information from NextWave or Vectric. I've talked with both of them, and all I'm told is they are working on them. Ready to Control, you can run a tap file through Ready Control just like you run it through your Pendant for the lasers. Ready2Raster does not require your computer to be connected to your machine. Ready2Raster runs very similar in the setup of creating a file like VCarve. So any idea why when I burn the laser grid pattern, I don't get anything on a piece of birch? It's probably because the Shark lasers do not burn well on light colored wood. That's the main reason. Is it the type of laser? It's a diode laser, as I mentioned earlier. It does not burn on light colored wood very well. So you either have to run it twice, run it extra slow. Those are a couple of the strategies for dealing with that, but that's one of the limits. So if somebody says the dark spots or scratches or imperfections of the material, question mark. Yeah, probably. Like I said, I was using MDF for this. So I probably have some scratches or something like that on the MDF that was seeing that. It's interesting. I did some samples. I don't have them in this presentation right now, but I was working with some pine the other day, and clearly the different color and grain or a little knot will burn differently because of the color of it. The question appears to be VCarve laser. Is that an issue with text? The VCarve laser app will cut text. It cuts it a little slower in some situations than the engraving app. And again, I'll compare those live as we go into the demo. So the question came up about 2 watt versus 7 watt on cutting. The 2 watt is not intended to do cutting. It's strictly an engraving tool. If you want to cut anything of any, and again, you're only talking like veneers or very, very maybe 16th inch plywood. You might cut through 1/8 inch plywood, but it takes multiple passes even with the 7 watt. The 2 watt, I would not plan on attempting to cut anything. You might cut some fabric with it, but or maybe some colored paper, but you're not going to cut anything thicker than that, if even that. And the question comes up here about using their laser on the 4th axis. Yes, that is a request that NextWave has on their list. We've had a couple of people who do custom post processors make it work, sort of. Of course, one of the limits, when you saw the setup, you've got that 1/10 of an inch clearance under it. So anything but strictly a straight dowel, if you have any highs or lows, the laser will have difficulty following those because that shroud is going to bump into any of those highs and lows. So right now, NextWave is not supporting that as an app because they foresee too many issues with contours and such. But I have seen a couple of people who pulled off a custom post processor they built themselves using NextWave has by the way, a post processor guide out there that you could download, and they modified their own post processor to make it work somewhat with it. Question is, why do you set laser power the 7 watt to 50%? The 50% for the 7 watt is a default speed. 50%, 100 inches a minute, is a starting point for kind of like all kinds of material or average medium grade material. So the question is, can I use Ready2Raster with my HD3 at a 7 watt? That's going to be a good question for tech support. I'm not that familiar with the HD3, but if you give tech support a call, they may be able to address that. What's the height of the unit? But yeah, your FX, you're going to have a little bit of a challenge. One of the things that some people do is they pull the router up as high as they can in their mount. I even saw one guy who did a little special bracket. It is actually able to mount his laser up inside his mount. So he did like a donut, like a reducer, and then he mounted the laser inside that reducer so that he maximized the amount of Z travel on his Piranha tool. So that might be an option you could consider also. And you could make that donut on your CNC. So the question is, why can you not laser on glass? Yes, because it's clear. The visible light just goes right through it. It also doesn't have enough power to engrave it, so it's a combination of those. But primarily, that's like acrylic plexiglass. The light is hot enough because obviously it burns wood, so it would burn acrylic. But because acrylic is typically clear, it'll go right through it. Yes, you could paint it and laser, but you'll only be lasering the paint. You will not be lasering the glass because it will not penetrate that. Again, the question is, does basswood burn well? Basswood is going to be a light colored wood. So again, that's going to have some challenges because of its color. I've burned a lot of leather because I do a lot of leather working, and I don't have any samples here tonight, but I actually was experimenting because leather's fairly light as well. And it also is combustible. So I actually at one point wet my leather, which gave it a slightly dark color. It was still kind of an experiment. I think the water, of course, offset some of the dark color as far as the burn, but I did get decent burns on it. Leather is actually a nice material to work with. I don't know if wetting your basswood, giving it a slightly darker color would make a difference or not. I've actually not tested that. How does Aspire fit into this laser work? The apps that you could buy from VCarve are the same. If you choose to use those, the engraving toolpath that we're going to look at is identical. It's really all the same. What Aspire has to offer versus VCarve really is just that Aspire allows you to create 3D models. So it has no difference when it comes to lasering. One of the apps that VCarve has that people are looking forward to having it fully compatible with Shark is the fact that you could laser to the top of a carved 3D model. But again, you have that clearance issue with that shrouder on the laser, much like in rotary work. So there are some limits there as well. I think one day we're going to see some of these lasers that have much more clearance. So the focal length is much longer, which will allow you to get a ½ inch or maybe an inch above your material. And then you're going to be able to do a lot more of the laser work on the 4th axis as well as on 3D models. I know there are some lasers out there that are already doing that. And I believe sometime in the future, Next Wave will probably go in that direction as well. So that's good news. So smoke extraction from your laser, that is definitely a concern. I've seen people, build basically just a wood box around their CNC and then put like an oven vent on top, or just get a small CFM fan on the backside with some clothes dryer duct and vent it out through a window. Definitely, if you're going to be doing this in a small room in the basement or in the house someplace, want some ventilation, right? So there are some limits in running the laser and 4th axis depending on your setup. If you have the added driver card inside your HD tool, you actually are able to run your 4th axis and the laser at the same time, because then that front plug for the laser box isn't needed for the 4th axis, but you do need to add that extra driver to your control box, and this only applies to the HD tools. If you have a Piranha, it will not, that setup doesn't work. How thick of leather can you cut? Again, it's much like wood. You're probably going to cut leather no thicker than 2 business cards. Well, you might cut thicker. It just takes a lot of passes. I have cut some, but it just takes a lot of passes. And the other side problem with taking a lot of passes, it just does a lot of burning. So the edge becomes very, very charred. Why doesn't paper and fabric catch fire when using the laser on it? Sometimes it does, so don't leave your laser unattended. I was burning some cardboard the other day, and it just kept burning. Something in this cardboard, it just wanted to ignite. Meanwhile, I did some etching on some paper to work just fine, so I'm not even sure. Something in the chemical composition. I have cut fabric, though, and I haven't had as much of a problem. I'm not sure why. So let's see. Yeah, multiple passes don't be afraid to do that. Can you use a laser in the SD110? Generally speaking, no. You can do some vector cutting, but right now the rastering, it is not compatible with any of the rastering tools, like Ready2Raster. It's not compatible with that. You can use it for a basic G-code file, which the quick engrave tool we're looking at. This is something they're looking at adding for the rastering, but that's one of the limits with the SD tool. So cutting with the 7-watt laser, this is one of those where it's 100% power, take the minimized burn off, and then, again, do a little practicing. Start out at 100 inches a minute with 100% power, see how it goes. If you want to slow it down to 50 inches a minute, you get much hotter burning. Again, it's kind of a balance between multiple passes and sitting in the same. Obviously, if you burn too slowly, you're going to really char it a lot. But if you go a little quicker, you won't get as much charring, but it's going to take more passes. So some experimenting is required. Again, you're talking pretty much thin materials, wood veneer, some very thin leather, thin fabrics, papers, thin cardboards. That's the most you could expect without putting a lot of time into the burning. Yes, the Next Wave instructions suggest that the Next Wave of the 7-watt laser be set up with 50% burn power. That is just a starting point. Again, the starting point is 50% power, 100 inches a minute. And it's just the opposite for the 2-watt. It's 50 inches a minute and 100% power. But you can vary those as much as you find necessary for your particular material. Okay, I'm back. We're going to take a look at VCarve and the 3 primary ways to do drawing and prepare files for your laser within VCarve. Start out with the most basic. If you have any type of vector shape, squares, letters, You can think of it a lot like V-carving in the sense that you've got, enclosed shapes like this. The engraving toolpath is actually a toolpath that is used for engraving in metal plates, much like you see on trophies. That's really the purpose of the engraving toolpath. So if we open it up, you're going to see settings here that really don't have anything to do with laser. In fact, this nose cone one seems like it should have something to do with laser. It really doesn't. It has to do, a nose cone on a engraving tool is a little like a presser foot on a sewing machine. It helps hold the material down when you're engraving it. But this engraving toolpath has been adapted to be used with laser work. And it actually works very well. It's been the default way of doing it for many years, and it actually works really well, very simple. So first of all, I'm just going to go through the basic setups because we need to set up a tool to use with the engraving toolpath if we want to engrave a shape or a letter. Next, I want to look at adding a tool to the tool database that we'll use for laser toolpaths when we use the Quick Engrave toolpath. So I'm going to open up the Quick Engrave, go into Select, and I don't have any laser tools set up in here right now. So the first thing I'm going to do is add a category or a group, and I'm going to rename that group Laser Tools. Click on that, so that is renamed now. Click Apply. Also, I want to make sure that I have my current tool selected, which is the HD510. And I'm also going to go over to this list and drop it down, and I'm going to select MDF as my default material for this initial setup. I can change the materials later, but for now I'm going to just use MDF. Now that I have my laser tools group set up, I want to add a tool to that. To add a tool to that group, I click on this plus sign. For the Quick Engrave toolpath, I'm going to use an end mill. And I've already got a name up here, but to change the name, you just simply open up that little icon and you can overwrite whatever is showing in here and then type in the new name, whether it's the laser 2 watt or the laser 4 watt. And now that I have that typed in, I'm going to set my diameter at 0.01, grab just a single flute. You may get some settings below here that it will ask you to copy them from. It's not necessary to worry about that right now. So for this first setup, I'm just going to simply click Create Settings. And now I have my usual end mill settings. Now we're going to use an end mill in a special way for the Quick Engrave when we set up for the laser. So first of all, I'm going to set the pass depth very shallow at 0.001. Set the step over at 0.1. And my spindle speed, the spindle speed actually refers to the power setting. This is how this toolpath is used in a special way to make it work with laser. So 1,000 means 100% power. 500 means 50% power. So for the default setting for the 2 watt, I'm going to set it at 100% power. And then our feed rate is going to be 50 inches a minute, which is going to be the default feed rate. And plunge rate we don't have to be concerned with because it doesn't apply to the laser. So with those settings set up, I can click Apply, and I now have a 2 watt laser tool set up. I can now click Duplicate on that, go into the naming configuration, rename this the 7 watt, click OK. And now it's asking me, do I want to copy those from the 2 watt? And that's fine. So I'll click Copy. And there's no the changes. Well, there are changes I'm going to make here. I'm going to change it to 500, which is 50% power as a default, and the feed rate of 100 inches a minute. Again, we could go back later and change those, but those will work for the defaults, and click Apply and decide which one of these you want to use for this toolpath. For this case, I'm going to go ahead and use the 7 watt. So I'm going to click Select. And then we can now see that the 7 watt laser is set up for this Quick Engrave toolpath. We also can edit that just for this occurrence if we go into the edit window, and we can change the settings. If I wanted to change my power to 80%, I could retype that. And if I wanted to change my feed rate to 120, I could retype that. And that will change the settings just for this single occurrence of the Quick Engrave toolpath. Because if we go back into our main database through the select window, you'll see that the 7-watt settings are still the same as they were originally set up. So that's how you would add a tool for the Quick Engrave toolpath. So let's take this T here. Let me zoom in on it. I'm going to actually split these windows. Then within this setup, your depth pressure, you want to put that at 0.001, which basically is similar to the plunge. You just want this very tiny amount of movement, if any, on that Z-axis. It's basically staying at 0. Now for this one, I'm going to put a fill. The outline would just simply go around the outside of the letter, as you can see in the picture, but I'm going to put a fill. I'm going to use a step over of 0.03. And this is strictly an artistic decision, what you want it to look like. You know, given the width of your laser line and the spacing, the size letter, it depends on how much of a fill you want. So you can play around, you can simulate it in the picture here to see what it looks like. You could do offset, which goes around, like you can see the picture showing. It does an outline or racetrack around the inside, or the hatch. You could also do a cross hatch or just a single hatch, and you can set up the angle. Again, nose cone doesn't apply. We're going to skip all the way to the bottom. There's double settings here for saving. You can save directly from here and put that right in your thumb drive, or you could save the traditional way and just go back to the toolpath line. I usually just go to the bottom and calculate so I can preview it. So if we look at it, there you can see the crosshatch lines. Now, since we have such a small router bit and are cutting to such a shallow depth, when you preview it, you may not see anything. But also you can augment it a little bit by changing the toolpath color to black, and that may help in this case. And there it is. So this one actually shows up. So that shows a bit of what it's going to look like. It's a very light path. Of course, you go in close, it's going to be all pixelated. But that will simulate your design. And again, you can use that as far as your understanding your crosshatching. If we go back in here, let's put in a crosshatch, a big crosshatch of, say, 1/4 of an inch, a hatching, and then cross it and recalculate. There it changes it all up. Let's preview and re-preview it. So again, it's strictly an artistic question. Now I'm not seeing some of the details along here, and that's again because it's carving in such a shallow amount that VCarve doesn't render it, but it will burn. So now we close that out. Now if I want to save it, you go through your usual save, just like you would for any toolpath. You bring up your save window, you highlight it, and then you need to select your laser toolpath and then take and save that out the usual way. And then you click save and you save it to your thumb drive, just like you would any fold file. So some of the other options within this Engrave toolpath, like I said, you could just do the outline or offset. You can do an outline, go around the side. So if you're cutting an object out of paper or thin material with a 7-watt laser, then the outline setup is what you would want to do, because you can really think then of your laser like a little tiny router bit that's going around the outside, or it's really going to cut on the line. You do need vectors for that in order to make this work. But I'm going to move on to the next item here, which is the 2 VCarve toolpaths. These are the apps or the modules they refer to them as. They're really toolpaths that you purchase from Vectric for $50. The first thing I want to look at is setting up the tools for the Vectric laser apps. They require a couple special setups that are different than the engraving tool. So we'll take a look at that now. To set up the tool for these, it's different than what we set up for the Quick Engrave. And so you simply click on either one of these, opens up the toolpath. We're going to go into the database by clicking on select. As you'll notice, there's nothing here. Once again, I just want to verify that I have my correct machine selected in the upper right, as well as I'm going to use MDF as the default material. So I'm going to go to the bottom here and simply select Add, which will add a laser cutter. Now it added the 2 watt. I could change that out by clicking on the little icon And there you can see it has the default. So this is pre-programmed now based on some settings. So actually, I'm not going to change anything on those settings. I'm just going to cancel out of that. And because those settings are bringing information, pulling information from the information below. So this is a 2 watt. I'm going to set up a 2 watt, hit create settings. Kerf of 0.01 is fine. Number of passes at 1 pass is fine. Power 100% for the 2 watt is fine. Move speed, however, I'm going to put that down to 50% as the default. We can change that later within the toolpath window, but we'll set that up as the default. The maximum burn rate is strictly for the preview purposes. It basically burns darker the higher the number, up to around 500 or so. When you go lower, it fades out. So I put that at about 500, which seems to max it out. It has no effect on the actual burning on your wood, however. It's just strictly for illustration purposes when you preview the toolpath in VCarve. I have these settings set up, so I'm going to click Apply. Now, if I wanted to create one for the 7 watt, which I do, I'm going to hit the duplicate sign here, the icon. That'll duplicate it. Now I can go in and click on 2 and change that to 7, and notice how it changed it to 7 watts in the label up here. It's an automatic update. I'm going to go ahead and copy my settings over for my 2 watt and my MDF settings. Click copy, and then I'm going to change my power setting from my default setting to 50% and my move rate speed to 100 inches per minute. Now I have default settings set up for both the 2 watt and the 7 watt. This laser cutter toolpath that we have set up here is different from what we set up in the Quick Engrave, and it's unique to the 2 toolpaths of the cut and fill and the laser picture from Vectric. So let's go ahead and just select that and close out. Now if we go into our main database, we can see that we have a laser tools group up here, which is used for the Quick Engrave. And we have our laser cutters down here, which are used for the 2 special Vectric Laser apps. The first one I'm going to look at is appropriately called Laser Cut and Fill. So it does essentially the same thing as the engraving toolpath. You could cut, but here you have the ability to cut on the outside of the line or the inside of the line or on the line, as well as a hatch fill. So those are a little bit different. You also can control your power settings right from the front up here. So if I wanted to change, so I've got a 7 watt laser up here. If I wanted to power that up to 80% and speed it up to 160 inches a minute, I can speed it up there as well and change those settings directly in that setup. I can also control the number of passes. So if you're doing a cutout, you could set this up for 4 passes and it would just go back and do 4 passes simultaneously. So it is convenient for that type of work if you're doing a lot of cutting. But again, your abilities to use even the 7 watt for real cutting are very limited, but you can simulate this also multiple passes. If you went back to your Quick Engrave, and if I took that Quick Engrave and let's set this up for an outline, calculate that, there we can see it's doing the outline. And I wanted to do 4 passes. What I would do, I would click this duplicate toolpath button, 1, 2, and 3. I would highlight all of those. I would do my save, and I would click all visible files into one, and it would save all 4 of those into one toolpath on the thumb drive, one file, and then it would run them, say, one right after the other. And it would be simulating the multiple pass setup of the VCarve app. So going back inside cut and fill, it has some advantage as far as its ability to do those setups, but the actual function of it is very similar. Now, we'll take a little look at these other features down here. You've got your step over, which again is much like your distance between the hatch lines. What we had before, you got your hatch angle, that's all understood. But I'm going to put some type in here. Let me change this up a little bit. Okay, let me close out of this and turn these guys off. Now I'm going to do an experiment or a setup here rather for the couple of the extra features within the hatch setup. So let's say we want to hatch this design. We're going to do a fairly large step over or spacing between the lines. We're going to hatch it at 45 degrees. And I'm going to select this option called Fill Together and click Calculate. Okay, so observe here how the tool travels. Fill Together means that it's going to cut the line on the L, move up here to the E, move up to the S, and it's going to take full paths back and forth. So all the red lines are when the laser's not firing, the machine is just traveling, and it's going back and forth in big, long swipes. So obviously a lot of travel. That's called Fill Together. Now, if we do Fill Regionally, notice how it'll change up the action. Now it's just taking the T or the E, and it's selecting the E as a single region, and it's going back and forth, skipping over the empty spots to do the E, goes over the S, and does all of that. And you keep refining it with these settings. So the next setting is Fill Regionally within vectors. And now you'll see very few red lines in between, except for the ones that are moving between the letters. So why would you do one over the other? It's basically a time savings thing. If you were cutting out parts, or if you were cutting holes, some of it may not apply because our lasers are not used as much for cutting. But clearly you could see you would have less movement and it would save some time with some setups. It might also be the kind of thing that you really want to focus on just doing one piece at a time and not jump back and forth between the others, especially if you had a large sign or something like that with objects in the 4 different corners. So that you could experiment with that as far as what those items, what those do as well. Again, crosshatch is good to give you the crosshatch. Well, much like a regular toolpath, if you had a 3D model, you could actually burn it on top of a 3D model. Once again, the limit you have with the 2 or 7 watt is you have that shroud with limited clearance. So it's not a real practical option unless you have a very shallow dish that you're doing that inside of. Once again, I can calculate that. Now you'll see it actually is a laser cut. So it's a different kind of file that you get with the Quick Engrave. It's actually a laser file. It's a different kind of G-code file, and it actually looks different. So the next one I want to look at, we'll take a look at in here, is the laser picture option. Now, the laser picture option offers you some options. Now, again, unfortunately, this is not very functional with, or at least fast, with the current Shark setup. But I think it's worth taking a look at anyway, because it has some nice features that eventually, when they get these systems worked out together, it's a nice feature to have because it does some fun stuff. So first of all, I'm going to bring in an image, bring in a bitmap, and let's select this guy. And what this allows you to do is called a raster. And what the raster does, it just goes back and forth, much like we saw, just a lot of linear lines that are being burned. And then the intensity or the power is varying. So you get a lot of gray varying lines going back and forth. You can set your spacing. In this case, it's set at 0.02, which is about the width of the 7-watt laser. If I exaggerate that and go up to 1/10 of an inch, and you could also do your line angles. So let's put that at, say, 30 degrees and click Calculate. You can now see both here, you can see how it's going back and forth. It's burning very light. Well, it's actually the opposite. It's burning dark here in the background and light on the object. It's reversed in that preview. If we look at the toolpath here, again, you can see those raster lines going back and forth. If we actually preview it, let's see how that looks when we preview. Sometimes it's successful and sometimes it's not. If I change my toolpath to black, it doesn't make a lot of difference, but you can see it if you zoom in close, it is there. Just doesn't provide a better view than that. Even if I made it denser, you would see a little bit more. I can do that. Let's make that back to 0.01, make it close, and we'll take and calculate that. And obviously it renders it better because the lines are closer. Reset it and re-preview it. And there we can see the preview. Now it definitely shows up better because the lines are closer. Now what I found in my actual testing is I showed you, you tend to end up with a little bit more of a pixelated background than what you see here. But it's worth some experimenting because it's a new tool and some of it depends on the kind of photograph you have. And of course you have pretty much unlimited settings for rendering that. Well, let's go back inside the tool again. And rastering is just back and forth. Again, that's going to give you probably, it's trying to duplicate that gray image most accurately. Now, a hatch is really a crosshatch in this case. And if we calculate that, we may not see a difference at this point because the lines are so close together. Reset it and preview it. There is a little tool bouncing around down there, but it's very small, so you really can't see it. Again, it looks good, and under normal circumstances, when the systems are fully compatible, the VCarve app and the laser setup, you do get really nice burns with it. But we're going to have to wait for that with the next wave setup. Again, looking in here, you've got the hatch. You can do a dithered image. Again, a dithered image is the one where it varies a lot of lines of dots and dashes to give you the coloring. I find dithering, like I said, within the Vectric tool to give a different type of results than the Ready2Raster, which we're going to look at in a little bit. But that's another setting you can experiment. So if you've got this app, you're experimenting, you can certainly try multiple options here to see what each of them do to give you the look that you like. A lot of settings there. The one that's fun that I look forward to someday being able to use more often is if I go into this file in here, let's take and I'm going to move this off to the side for now. There's a little app function in here, a little tool called Vector Texture. And it basically creates a group of random lines on your drawing area. So in this case, I'm going to set those lines at 45 degrees. Line spacing, let's set those line spacings at 50 thousandths. And then variation, for this setup, I'm not going to do any variation because I want those to be even, because what I'm going to be doing is lasering on these curved lines. Amplitude has with the height of it, and then the length of it, and the noise I want at 0. But these two I can play with if I want to change those. Let's preview it. And there you see if we move in, they're really close. Let me just back it off just a little bit further so you can see those curved lines a little better. Now, you're going to want to, if you actually use this app, you're going to want to make that line spacing a line spacing that is similar to what you would have used for your raster spacing, your hatching spacing over here, because the lines have to be a certain distance. Let's try those and see how it looks. So there we can again see our lines. What I'm going to do, though, is I need to move my Eagle design back to the middle. I now need to select those lines, selection angle around everything. Now let's see if it'll calculate. You can see the lines on here, how they are cutting along those curved lines that we designed up here. It's really a wavy raster. You can actually make out the image if we preview it. And let's go in and you can see it there. Again, you're not going to see it real well in this preview. It's a really nice tool. Like I said, I'm really looking forward to when NextWave and Vector work out the differences in the program, because this will be a fun one to create some creative laser work with. You could make that, you could take this guy and you could actually copy it and flip it and make a curved crosshatch out of it as well. The options are really unlimited. You could even go in and do vector tracing around the eagle head, do one kind of pattern on the eagle head and another kind of pattern on the background. You could do square cross hatching on the background, curved cross hatching on the front, and it's just a lot of fun that way. So before I jump over to Ready2Raster, I'm going to just check the chat here a minute again and see what other questions might have come in. Burning on wooden spoons, it's a challenge. Any sort of curved surface. Now, both the lasers have a little bit of focal length or a little bit of focus length that would allow you to have a little variation of the height and still burn. You'll discover it fairly quickly because it'll go out of focus and won't burn well, or it'll give you a thicker burn. So you can play with that a little bit, but there's no real easy solution for if the spoon has much curve to it. NextWave is looking at probably coming out with something more powerful than the 7 watt. There's some new technology in the market. It's fairly fresh, so they want to prove it out first. I doubt we'll see anything before the end of the year, but there's always talk of trying to get more power out of the laser system on the NextWave. So hopefully we'll see something like that. So when you've seen me, I'm not sure. So the question seems to be, is in VCarve laser module, can you use speed settings greater than 100? Yes. In general, for the next wave tools, the HD tools in particular, that the max speed of the HD tools is 200. So you can speed it up. The default settings I'm using here of 50 and 100 or 150, depending on which wattage I'm using, are just default. It's a starting point. I ran some files the other day at 200 inches a minute, and they burned fine. I cranked up my laser to 100%. There is some discussion out there. You'll see that some people feel you get better photographic results if you actually run slower with a lighter speed or a lighter power at a slower speed than a faster power at a higher speed. So a little experimenting is worth trying there. But the next wave tools are capable of doing up to 200 inches a minute. Now, you won't always achieve that because just like when you drive your car, when you go down a straightaway, you can go wide open, but when you come to a turn, you got to slow down. So next wave tools automatically slow down when they go around a turn. And much like this wavy line design we just saw, that's all curves. So it's possible that the next wave controller overpowers the speed setting, and it's like a governor. It automatically governs down the speed of the tool to a safe speed so the tool doesn't skip steps with the motors and that. But and on straightaways, you can get the work done pretty quickly at 200 inches a minute. Oh, here's a good one. I'll actually demonstrate that. So the question is, can you only do photographs? No, you don't need to just do photographs. In fact, I have a sample here to show you what else you can do. So I'm going to bring in this dog face right here, and I could use I would need to trace that in order to use the cut and fill or the Ready2Raster, or rather the engraving. But I could use this design and do a raster on it, much like we did before. I'll just use some default settings here. Let's go in and change that one up a little bit. And let's speed this up. Let's go maximum on this. Let's go 100% power. And I don't really need to worry about the minimum powers because it's not varying. And then move speed, I'm going to go 200 on my HD tool. And I'm going to calculate that. So if we preview it now, see how much render there. So it actually did a nice burn. So that's using just a piece of clip art. And it did a full fill on that with the settings I had. And it did a very nice black burn all the way around. And that's using the laser photo op from Vectric. Now, again, that is probably going to take a long time, and the results may not be as smooth as with Ready2Raster, but you can also do this in Ready2Raster. So I think when the apps become compatible with Shark will make a big announcement about it. So you'll get it in the newsletter. It'll be noted probably on the laser page of their website. They'll make a big deal out of it when it happens. So you should be able to find out. Before I leave VCarve, let me be clear about something. This Engrave tool right here, Quick Engrave, works really well with vector lines. It won't do the fill that we just did, but it works really well with the Shark tool. It works really well with doing cross-hatching, outlines. You just need to start with vector lines like you do with CNC. If I trace this dog using the bitmap tracing tool, I could actually use it. So let me just do that as a quick example. Go over to the bitmap tracing tool. Always takes a little while to open. Let's enlarge that here. So I'm inside the bitmap tracing tool. I'm going to just accept all the defaults, hit preview. There I created some lines and apply that and close that. Go up and turn off my bitmap layer. And now I have these vector lines. I now could use the Quick Engrave tool to essentially do the same thing I did with the other tool in Vectric. So let's just see here, step over, let's make that close. And let's go down to the bottom, calculate. And so now when I preview that, change the tool color. So that is done now with Quick Engrave. So just to be clear, you could do a very similar illustration with graphics like this with the Quick Engrave, as long as you trace it first and then you have vectors to work with. So Quick Engrave requires vectors. It's fully compatible. You do letters, shapes, designs like this. You just can't do gradation with the Quick Engrave. It's either black or white or the solid gray color, depending on how much your hatch is. Again, I get the question here again about when this might be resolved. I don't have an answer when that might be resolved. I've talked to both companies and they're working on it. That's all I can say at this point. When I say inches per minute, it's the feed rate I'm referring to. And there's a question here about, for just black lines, like for the dog, could you use the Vectric Laser text tool? Yes, you could use the text tool and you could just do an outline around that dog, but you could also use the engraving tool to do an outline. So here I'm inside the Vectric Laser text tool and I'm using an outline. It would just follow those lines, but I could do the same thing with engraving. So they're very similar tools. The results are very similar. And yes, any of these tool paths, then you would save out the usual way using this and the laser post processor, and you would save those out to your thumb drive, take them to your tool, and you would run them just like you're running any file in your tool. We went through that earlier, kind of the workflow. There's a couple more windows you have to click through and the setup, but the basic workflow is very similar to using your CNC in the conventional manner. So let's go ahead and hop over to Ready2Raster at this point. Last question before I move over to Ready2Raster. What do you recommend, 7 watt or 2 watt? The 2 watt is really a good choice. It takes a little longer, but what you get out of that is a very fine line to do very realistic photo engraving with the laser. So if that's really of interest to you, if you're looking at doing heavier etching, outlines of letters, boulder type work like that, and even cutting some light thin material, well, then obviously the 7 watt would be a better choice for that. But the 2 watt has a very, very fine line. It's very impressive. So if you're doing real detailed engraving, there's been some people who have engraved like maps with little tiny lettering on it. It does a great job of that. Again, it takes a while because it's not as powerful, but that's the compromise you make for the improved quality of the very, very fine line that you get with that. Okay, I'm going to hop over to Ready2Raster, and let me first of all bring up the web here, and let's go to the Next Wave website and go under support. And if you go to your portal login, sign into your portal or your account, you're going to see Ready2Raster free software, and I already have it, so it shows that I already have it installed on mine. You click download, and they just created a brand new version today with a few tweaks and improvements to it that they've been working on over the last few weeks. I nudged them on a couple of things that I thought that they ought to do, and they moved on those as well. So we're actually going to look at the most recent version right now. And if you want to use Ready2Raster, go download the new version first, because the old version had a couple bugs in it. So let's go into Ready2Raster. So as I mentioned, Ready2Raster is a free program from Next Wave. Its intent is for photo engraving, much of what we've been looking at. It's a very straightforward program. There are some advanced settings and some basic settings. So I'm going to go kind of through the basics. We get the program up. The first thing you want to look at up here is your settings window. And this is where you can set up your basic tool, your defaults, okay? So right now I've got the 7 watt selected. I've got its default power is 72%. That was just a random number when I was playing with this earlier. Let's set that at 50%. And I'm not going to use materials for my defaults, and I'm going to use a lower left. We'll come back to talk to more about this as we go along, but these are the basic settings you want to look at. And I would duplicate these. If you're using the 2 watt, of course, crank it up to 100% and take your laser speed down to 50. So it's the opposite of what I have here. And I can just close this. For those actually to apply, I actually need to close the program for the save and reopen it. And I'll show you where those defaults pop up here in a little bit. So let's go ahead and load an image. I'll go into my files. Let me grab my Eagle, say open, and there's my Eagle image. Now, the first thing that automatically opens up here, it shows you how big that file is. So full size, that is 20 inches wide. I want this to be only 5 inches wide, so it automatically scales it in height and width if you have this maintain aspect ratio checked. So that's the basic setup. Then you have convert to grayscale, so it's going to turn it to a grayscale. Now in this window, the top half of this window are advanced features. I'll come back and look at those at the end, but for most of the work, and I would say 99% of the work that I've done recently, I just ignore those because I found I actually really don't need them. There are a couple occasions where you could use them to tweak things, but unless you have experience with Photoshop or photo editing, these settings can be really tricky to master. So I found I get good results by just ignoring them for the most part. We will talk about them, but not right now. The main item I'm interested in here is dithering. Now watch when I click that, it automatically applies the dither to the screen. And that again is showing you what it's going to eliminate some of the data, give you that dot pattern. Now sometimes photographs will import opposite. So sometimes you import a photograph, it'll look like that, like a negative. Well, if you click on this invert, it'll flip your negative to a positive. So you could, that's the purpose of the invert. It's simply functional. Some photographs for some reason come in opposite, or maybe like that dog head that I imported, you want to flip that the other way around. So you want a black background rather than a white background. So for graphic images, you can very quickly flip the image as well. But I'm going to select dither. And now I'm going to go down to my laser settings. And this is where you see my speed of 150. These are the defaults that came up. And those are the defaults that carried over from my settings window. Now I can override both of these here. I can type in 120 and I can take my speed up to 60 and that'll stick for that setting. So I can manually still manage those. Then I go down to this window and it's just giving me a chance to verify my datum point, my start point, and if I want to resize it again. And when I click on save, it's going to save a tap file. And let's call this Eagle 3. Click save. And then you get this option that says, would you like to load the raster back in to verify the output and make further changes? This option is a little bit still in development. If I click OK, you're going to see a grayscale image here, which is trying to simulate what the burn will look like. You don't see the dithering in here, so it's not that accurate. So I usually, because I'm comfortable with my settings, I usually just skip that and go back to my file and go to my machine and cut my file. If I were to go back to these settings now and I go back and hit dither, it will dither that one, but notice how it's already a modified image. So it's dithering it a little bit different. So I always go back and reload the image back over again for a fresh setup if I want to do new settings. So at this point, I would not recommend trying to backwards engineer your design, start fresh again, work your way down through the settings. It doesn't take long. There's not that many of them. Click dither, setup. In this case, maybe I want this to be 100 and change this back to 50 and go back here to my preview. Now, one of the things you're going to find that if you don't do dither, you're going to get just an even gray burn. And it's very similar. It's more like a photographic burn without the dither. But I find that the dither, removing some of that data, actually gives a much more pleasant image. But you can do this as well. You will get a much blacker background. So you may have to play with your settings. But it's one of those things that you can just do a couple of tests on. You know, like I said, that burn took me about 28 minutes, 30 minutes. So it's not a lot of time to do that test. One thing you may notice, if I save this, and let's give this a Eagle 4 number, and it's offering me to bring it back in. Now, some designs that you import in here, it's going to depend on their size, but some designs, in fact, I wonder if I could force it. Let me try this. I want to show you a window pop-up. Try it one more time here. I'm going to leave that full size, and I'm going to go ahead and dither it, default settings, and save. And it takes a little while to save it because it's a large file. Okay, this is the pop-up that you may see. Due to the resolution restrictions, the resulting raster will be performed in 2 individual columns. What this means is when it burns on your CNC, it's actually going to burn the first half, and then it's going to go over and move and burn the second half because it's such a large file. And because it has 2 individual files, you're not able to do a preview. It also says use ready-to-control software to preview more complex files. Again, that's a bit of a work in progress, so we won't discuss that today because it's not a fully functional feature. That it's something they're working on and testing. But you may get this notice if you have a very large file, and it will in fact burn in 2 columns. It does a pretty good job stitching it down through the middle. It's not too noticeable. So I've burned a few of them and been pretty happy with it. Couple other settings to look at in here that are more advanced. Like I would say, if we go back to this grayscale, you have got adjust contrast. Let me take it off Dither for a minute. And contrast basically makes the whites whiter and the blacks blacker, or the opposite. It makes everything lighter. So you can adjust that, but many tweaks, it will affect your image. But unless you can do some testing, give it a try. Gamma primarily affects the mid-tone ranges. So if you think of the middle ranges, you sometimes don't see a lot of change. You don't see everything getting all white per se or all dark. It's pretty close to contrast, but it's a fine tuning way to deal with mid-tones. And again, if you're a photo editor, then you'll know more about that than the average person. Brightness is, again, much like exposure, basically takes everything black and makes everything lighter. So I'm just going to reset those to the defaults. Now, average grayscale and absolute grayscale. Average grayscale basically starts at the left side and gradually gets lighter to the right side. You can see how this light area is slightly dark on the left and lighter on that side. There are some manual bars in here that pop out right there. So what this is doing is that this area underneath my cursor, the black area, it's going to take all that information that was existing in this bird to the right side and make all that data, all those pixels, white. So you can see how the white items got whiter because it lightened up everything that was gray. The opposite occurs on the other side. It's a little tricky to use these because we move that one over. If I click too fast, okay, here we go. So now you can adjust and bring in the dark side. Now notice how my histogram here in the middle is gradated from dark to light. So basically, now all my gradation takes place in between those 2 bars. If I move it down here, all my gradation takes place between that information here. Of course, it's affected by image too, and that's why it's kind of complex. Absolute grayscale, it only chops off the right side all white and the left side all black. But the data in the middle, you'll notice, isn't changing any value. Again, it's a bit of an advanced setting. If you understand photo editing, that's what that does, and you could play with that. The other feature to look at in here that has some use is inside the General Settings tab, click down for more information, Material Database. Here you can create custom materials. If we take a look at Lightwood, Lightwood right now has a black value of that to white value. So there's a couple of ranges in here and a couple of settings. This, again, is a little bit of a work in progress, but if you wanted to create a new material, you could simply click that, add in your default speeds that you like. Let's call this Cherry. And I find that Cherry for the 7 watt, a black value. And again, I think to start with, I would just use the broad range of black values, but that black and white value, if you remember that burn chart that we talked about earlier, that's what that comes from. And you pick your range from that and you enter that. And that is kind of like this histogram, and it's manually controlling it. Again, these are all advanced settings. You can get nice burns without doing any of this. But as you start exploring this, that's one option that's available to you. And if I add another setup in here with a different speed for my 7 watt and a different black value range, let's say this is 20. Now I have a range in here, and the program will automatically calculate any other speed ranges based on the values you've put in here. So it helps to hone it in a little bit. Next wave I hear is working on a user manual for this. It'll all explain this in detail. And it's kind of interesting, but like I said, it's all advanced stuff. And for the most part, you won't need it for most of your basic cutting, but you can create your own materials. On the right side over here, if you remember that chart we talked about, this is where you could create that chart with those multiple graphs on, or those multiple grades, little areas of coloring where it burns at different levels. A couple dozen squares on it that it burns. And to save the chart, you simply hit save. It saves out as a TAP file. After you save out that chart, this is the full chart at 120 inches a minute for the HD5 7 watts. All the information is right there. Then you can go down. It'll automatically jump then to what's called the row generator. See, the chart generator is above, the row generator is below. And for the row generator, you're simply picking one row. So I could start out with a black value of 45 and generate a chart that goes up to, say, 200, and it will just burn black values from 45 to white values of 200. It's going to be 1 inch tall and 3.5 inches wide, going at that speed. And again, if I save that out, it'll add it to my file, and I can take that to the machine and burn it as well. The one thing you have to be aware of is that the labels on that chart, you know what? I'm going to hop out of Raster right now and jump back over and show you what that chart looks like. So that's what the chart looks like that I was talking about, and that we're going to burn. And this is the single roll. And right now it's going from 0 to 250. This is the full chart. The way you would use this is when you burn it out in your materials, either one of these charts, but let's take this bottom one. I'm going to choose a 0 value, go up to maybe 225 on it, because then it turns totally white. So those are the numbers I would then add in my material editor as the range of burning that I want, because I would drop off this extra white because it's not doing me, it's just giving me extra white area, and I want a better gradation. So I want it to spread out a little more. This chart, like I said, isn't a good representation because we have pretty much all white and one gray, and then everything else is black. It has to do with there was some overburning going on in this, and I believe they have fixed that now on the chart. But that's what the chart looks like if you want to experiment with that. But otherwise, use some of those default settings that I mentioned earlier with your different wattage and try a photograph, and you'll get pretty good results. Like I said, I just bought a big sheet of MDF, 1/4 inch MDF. I burned both sides with some of my testing, and then I go over to some of my cherry wood or some of my alder or some of my other mid-tone woods to create the actual final part. And you could actually do this chart and your test chart on your actual wood also. It even makes it better. But I started with the MDF because it's such a middle tone and gave me my general starting point. And it verifies what NextWave recommends, which are those speeds: 50 inches per minute with 100% power for the 2 watt, and 50% power and 100 inches a minute for the 7 watt as a starting point. So let me check on the Q&A here a little bit further as we're getting near the end tonight. So in burning clip art, is Ready2Raster better than engraving? Hopefully you see that it's two different things. Clip art, which is basically black and white like that dog face, can be done either way. You could use Ready2Raster to burn that dog face, and it'll give you nice black areas. It'll do this. It'll just treat that like black parts of a photograph, and the white areas will be white parts of a photograph. However, if you trace it with the vector tracing tool, the bitmap tracing tool, you could also cross hatch it. So it's really a different approach, and it gives you a different look. Can Ready2Raster be used with a control box? you have to have a way to get the tap file that comes out of Ready2Raster into your system. So if you have one of the older non-pendant tools, assuming you're bringing tap files out of VCarve and bringing them into your control panel, so the same file coming out of Ready2Raster then should go into that control panel as well. So it says, what is your recommendation for burning a photo on something you cut in VCarve? Example, you want to burn pictures with several coasters. Well, again, I think Ready2Raster is a good choice for burning photographs on something like a coaster. After you save your tap file, they are looking at re-engineering that to open it back up. It's a good question. Can you reload a tap file into this? Well, let's try it. If I open that up and it's saying load, and it's saying it's incapable of previewing that file because it has multiple rasters. That may be that one with those double rasters. Let's take one with the single rasters, the single columns, and load that. And it did load it back in. So yes, you're able to preview it again. But again, the preview is somewhat limited. You're going to see the same preview when you end it. But yes, if you had a tap file, you wanted to see what was in that tap file, you can do it this way, as long as it's just a single column file. You can reload it and preview it. Somebody's asking if you could load up an SVG file. You could load up SVG files in VCarve, but I haven't tried it. SVG files are vector files, so I'm not sure that they will load in Ready2Raster. Yes, the 2 watt would be fine for burning images on coasters. Well, hopefully I addressed most of your questions tonight. When you get my email, you'll have my email address, and you are free to respond to that if you have questions about setting up any files with your laser. All I ask is, like, if it's a VCarve file you're working on, send me a copy of your VCarve file. It's really hard for me to diagnose problems if I don't see the actual file or the actual artwork. We all do our best to describe the problem, but it's really tricky. And then sometimes it comes down to being a machine problem. So thanks, everybody. Have a good evening, and maybe I'll see you next time. Take care.